This is systems of equations, and one method of solving these is through graphing, which is maybe not the easiest way to solve a system of equations, but it's the best way to visualize what's actually happening with your two equations. So a system of equations, this is just a set of equations that we solve together at once. And you can either have one solution, all real numbers, or no solutions, no real solutions. So these are just some different examples of that. So here I've got a red equation, a blue equation. These are both graphing lines. They never intersect, they never touch. These are parallel lines. So these actually have no real solutions. There's no place where they cross and they share the same point. But the second one here, these lines intersect, looks kind of like halfway in between the grid here. So this would still be one solution. It looks like 1.5, 1.5. Right about there. And then the last one here, I have two lines. They're right on top of each other. They're basically the same exact line. These are all real numbers because you can pick any point along either of these lines and it's going to be shared by both lines. So these are kind of the three different things that could happen when we're solving a set of equations. There's also three ways to solve these. So today we're just going to look at graphing. And to graph this, we need the slope-intercept form, which is y equals mx plus b. Here, the y controls the vertical up and down, the y-axis. The m is what controls the slope of your line. The x is what controls left and right, so kind of this horizontal axis. And then the last number here, the b, this is the y-intercept, just kind of where the line is hitting on the graph, on the y-axis. So let's do an example here. On the first one, both of these are already in y equals mx plus b, y equals mx plus b. So these are actually going to be pretty simple to graph. So I can tell just by looking at the first equation that the y-intercept is 4 and the slope is -3, which just means I'm counting down 1, 2, 3 over 1. Down 1, 2, 3 over 1, and then down 3 over 1, just like that. And then really all I want to do is just connect those lines, or connect those dots with a line. There we go. And I'm going to do the same thing for the second equation too. This is also already y equals mx plus b. So I can tell the y-intercept is -2. I'm going to put a dot there. And the slope on this one is 3. So I'm just going to count up 3. 1, 2, 3 over 1. Up 3 over 1. Just like that. You can keep going too if you need more dots. Is fine. And then again, I'm just going to connect these with my line tool. There we go. So now I can tell, now that I've graphed these, they intersect right here. The solution to this system is just +1, +1, the point where they intersect. So here, let's look at a harder one. Neither of these are already in slope-intercept form. They don't look like y equals mx plus b. So the first thing I have to do here is subtract 4x from both sides to get that over to the other side of the equation. So that's going to be y equals -4x plus 2. So now this is in slope-intercept form, and now I can graph it. And same thing with the bottom equation. The first thing I need to do here is I need to subtract this x out, which is going to give me -y equals -x plus 3. And then I also need to get rid of this negative sign, just really by multiplying the whole thing by a negative. It's going to flip all the signs. So this would be now +y equals x minus 3. All right, so now I can graph both of these and I can see what they're doing here on the graph. So for the first one, the y-intercept is 2. I'm just going to put a dot on the 2. The slope is -4, so I'm counting down 1, 2, 3, 4 over 1. Down 4 over 1, kind of off the graph here a little bit. And for the second line, Same thing, so the y-intercept here is -3, and the slope is, this just says x, so there's really an invisible 1, visible 1x. So our slope is just going to be 1, up 1 over 1, up 1 over 1. All right, and you can kind of tell where I put these dots on top of each other, that's going to be our solution, but we'll still graph the lines here. Okay, so now that we've graphed the lines, we can see clearly the intersection right here is going to be our solution. This looks like it's +1, -2. All right, so that's basically it. This is solving a system of two equations by graphing them and then just visually looking to see where that intersection is.